Look at your Chapter 2 test review. Chapter 2 chapter. I was from Brooklyn for a second. From Boston for a second. Your chapter. You don't like to say Alright. So hey, if I had a histogram with some frequencies, let's say we went 10, 20, 30, 40, 50, 60, 70, and gosh, we were at 10, 20, 30, 40, 50, 60, right? And gosh, it looks something like this. Alright. If you had to estimate the mean and the mode of this data, where would you look? Where do you think the mean and the mode are going to be located in here? They're probably going to be right here, right? They're probably going to be somewhere in this group, right? So the mean and mode are, what we estimate, that's from what, 35 to 45? So one, that's the first thing we're going to look at. You should also be able to find the mode of a data set. I don't really think I need to give you an example. I think that you can just find the number that occurs most often. That will be fine. I'll try to have the ones that are a little bit different. I am going to give you some examples of them, all right? Okay, so let's look at another thing. Oh, you need that, so? All right, so a second kind of interesting thing. We'll go I know I'm being so creative with these numbers. We're going to have to compare these. fine. So, and I guess I'll do this as well. That'll be better. Okay. So hey, 3 stem plots, or stem and leaf plots, if you will. Which one? Yes. What? What am I gonna ask? Yes, it is. Oh wait, greatest standard deviation? Wait. You got it is backwards. Hold on. You got that backwards. So which has the greatest standard deviation? It's going to be the first one. You're thinking backwards, right? The smallest standard deviation is the one on the left. All right. So which one has the greatest standard deviation? So it is going to be this one, right? Because the data is more spread apart, right? Well, okay, they're very close together on 3.
Those are far.
No, those are far. They're more spread out. Think about it that way.
Or like there's more stuff here than there's here?
Yes, exactly. That's how you're looking at it, right? Yeah. If you got more data in the center, then you're going to have a lower standard deviation. If you've got data kind of spread out everywhere, then you're going to have a greater standard deviation, okay? So that one. This one has the smallest. Standard deviation. Oh. Just out the harmony. Yeah. Yes. Hey, we have seen a problem like this. I have done it for you. If we have an ogive or a cumulative or relative cumulative frequency plot, I always get those backwards. Relative cumulative frequency. How do you read that thing? So they always look like this. We really need a lot more ones. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Yep. That's better. So these are always going to go in tens. We're talking about percentages, okay? So these are percentages. 10, 20, right, all the way up to 100. I guess I'll go to 90. 30, 40, 50, 60, 70, 80. That is a 9. Okay.
Wait, so
Yeah, this is percentages. It's your cumulative frequency. But these are percents. Yeah. Almost done writing this thing. Okay. What if I needed to estimate the number in the sample based on this information? Okay. In the sample, so I'm going to say, what's that? Like the total number, right? How would I do that? Okay, so this is, what is this saying? This is saying that, where are we at? Let's look at this right here, okay? Let's say that it drops to 40, right? And then it's at 80. So it's saying that 40 is 80%. Or it's at the 80th percentile. And then, gosh, we're up above 100. It's supposed to look like this. Sorry, my drawing is not good. This is saying 70 is at the 100th percentile. Which means that the answer is 70, right? Whatever is at the 100th percentile, that is going to be your total. So guys, you should also be able to find standard deviation. I think that you guys are pretty good at that by now. Also, remember how to read a box plot. You're going to have to use the calculator. You're going to be given a data set. And then you'll have to use a calculator. And then you'll have to be able to read this, right? To know that this is your minimum. Right, we've written this down before. This is quartile 1. This is your median, which you could also call quartile 2.
How do you put what?
There's quartile 3. And your, right? Just know that that's how you read a box plot.
Okay. Cool. Try it. To be honest with you. But
Right.
yeah, I had to do the same thing because it kept saying that there were two number zeros. Alright. Yep, later.
So remember that if your data is skewed, right? So if data is skewed, and you guys have been asked a question about this before. Use median as the measure of central tendency. If data is symmetric. Use mean. So for instance, if I wanted to see, hey, what kind of was an average or a typical score on a test, then I had test scores that looked like this. 20, 15. So these are all test scores, right? I got a 20, a 50, 70, an 80, an 80, 100, a 99, a 98, and an 89. If I was to graph this data, right, we would notice that it's skewed to the left, right? Meaning there's a whole bunch of data over here, right? So if I graphed it, it would look, I don't know if I want to draw a curve, sorry. If I graphed it, and this is not the way it actually looks, but right, I would have a bunch of stuff over here and not too many data points over here, something like that. You know what I mean? Of course, that's not what it's going to look like, right? In reality, yeah. I'll take skew left and skew right. So and that's a better way to talk about it. So it's more, if you're going to be taking like the X-ray exam, they wouldn't use positive, they would use skew. So we'll stick to kind of the more standard things. Your book occasionally uses some terms that are not terms you would use in like upper level statistics. I feel like if you're going to wind up taking a statistics class, I want to give you guys, like in college or whatever, or if you're going to take one after this, I want to give you the terms that you're going to hear there. So just let's look at skew left and skew right. This would be positively skewed. All right. So in this case, this is skewed, and so we would use median. Okay, so you want to look at, kind of imagine what a graph would look like in your head. If it looks like it's going to be nice and symmetric, go ahead and use median. If it looks like it's going to be off to one side or the other, like the majority of the data, then use median. You know? All right. Hey, if on this test, imagine that on a test, the mean was realistically 72. The standard deviation, rather. I'm going to write standard deviation, SD, was 2. Okay? What percentage of scores were between 72 and 76? To do this, I can use the empirical rule, right? So I'm going to use the empirical rule. And I use the empirical rule, I like to draw a picture. Shoot, I like to draw pictures anyway. Remembering that if we're going to use this normal curve, our mean is right in the middle. What's over here? 74. This one should be 70, right? So I'm going 1 standard deviation above. So there's 1 standard deviation above, 1 standard deviation below. Right here we're at 68. We're subtracting 2, right? We're subtracting 1 standard deviation every time. That's 2 standard deviations above. Here is 3 standard deviations above, which is 78. So there's 3 standard deviations, and then right here, 3 standard deviations below is at 66. So if we want to know the amount that we're in here, right, that's what we're being asked for. What percent is in here? And you guys remember, you have a little picture in your book, right? It tells you how to break down all these percentages, right? This one is 34%, right? Because between here and here is 68%. And then in between here and here is, and I don't have the other ones memorized, I always have to work the math out. In between there and there is 95%. So I have to go 95 minus 68, 27 divided by. So then right here, and you guys have a picture that you can use on the test of this. That's 35%. So then, what percentage we're between? Wow. Between 72 and 76, we're going to add those percentages, right? So it's going to be 34% plus 13.5%. Or 47.5%. Alright, so you should be able to read a 7-leaf plot. So we'll go back to this picture right here. And let's look at this one right now separately, right? What is the minimum entry in this? The minimum entry is 11. Excellent. The maximum entry? 54. That's it. Alright, this means 11, right? This one means 54. So this is your max, because it's the biggest number in your stem plot. And this one is your minimum, because it's the smallest number, right? The other ones are, what, 12? Right? 12, and then 13, and then 14. So just be able to read what your minimum and your maximum would be from a stem plot. Okay. Oh, here we go. So another way to read a box plot, remember, oh, I better not forget this. Is, remember, since they're set up in the quartiles, right? We can find out what percent of all the data is contained in these by looking at them, right? From here to here, from your minimum to your median, right? That's 50%. Your median cuts it in half, yeah? From your minimum, to quartile 1 is 25% of the data, right? And it works the same on the other side. So even though it looks like that median doesn't cut it in half, it is indeed the case that it does cut it in half. All right. When we left off, the last for the problem that we did before we started going backwards, right? We had a mean of 72, a standard deviation of 2. Let's find the z-score for a student that got a 68% on a test, okay? So let's find the z-score. For a student who got Alright. So we're going to use our formula. We're going to use our formula. It tells us that z is equal to x minus your mean divided by your standard deviation. We're just going to plug in the information that we have. We know that our mean was 72 and our standard deviation was 2. So z equals our x, which is 78, minus 72 over 2, which is going to be negative 4 over 2, or negative 2. So my z-score is negative 2. And how do we interpret that in terms of a standard distribution? This means that if you got a score of a 68 on this test, your score was 2 standard deviations below the mean. And doesn't that make sense if we look at our picture here? Right there. 68 was 2 standard deviations below the mean. And the last thing you need to know is how to calculate your variance, right? So remember, and a lot of people have asked me questions about this, so I want to remind you again, that you get your standard deviation from your calculator, right? So on your calculator output, standard deviation is that SX, right? That's the standard deviation of a sample. We're going to look at the other one, the sigma X, later. But remember that this is your standard deviation on your calculator. And to find the variance, you're going to take this and square it. So you're going to square your standard deviation. You're going to multiply it times itself. And that is it. That is what is on the test. I'm actually going to cut a couple. There were 20. Or I might replace them. So let's say 20. It is all multiple choice. Okay? Alright guys. Good luck. Don't forget to study. Again, if you want to look this over, it's going to be on the YouTubes.